Good morning, all my dear and lovely students. I hope you are enjoying your online sessions. So, here today I have brought your class 8 mathematics, chapter 12 exponents and power, part 1 by your Sonali ma'am. So, this is very interesting as well as very easy chapter in entire textbook. So, we have covered under virtual classes. I hope you will enjoy part 1 presentation. Here we go. So, the chapter number 12, powers and exponents. So, powers, how will you identify in a number that this one is power and this one is exponents? Let's have a look. Now, whenever we write any number in the form of multiplication, or you can say a shortcut for addition, we use powers or exponents. Now, when you need to add the same number to itself over and over again, the multiplication is a shortcut way to write the addition problem. Now, instead of adding 2 5 times, 2 plus 2 plus 2 plus 2 plus 2, which is equal to 10, you just simply multiply with 2 with the 5 and get the same answer, which is 10. Now, how powers and exponents that we are using? So, they are the shortcut for multiplication. Now, you saw that adding the same number again and again. Now, what will you do when you had to multiply the number with the same number again and again? So, when you need to multiply the same number by itself over and over again, the powers are the shortcut way to write the multiplication problems. So, instead of multiplying 2 into 2 into 2 into 2 into 2, which is 32, you can just simply write that 2 raised to power 5 and get the answer, which is same 32. So, here with this chapter we are going to study a lot about the number which is multiplying again and again by its own or the other number. A power. A power is a number written as a base number with the exponent. So, base you always write at the lower and exponent you write always to the top. So, remember this. Here in example 2 we will consider or call it base and 5 we will call it power. So, we can say that 2 the 5th power or 2 raised to 5 or 2 the power of 5. The base, which is the bigger number on the bottom, the repeated factor in the multiplication of the problem, which is also called the base. So, when you have 2 multiplied 5 times, that is 2 into 2 into 2 into 2 into 2. So, your base is 2 and power is 5. So, result or the answer that you get is 32. Now, the exponent. The little number on the top right side of the base is also the number of times the base is multiplied by itself. So, here in this figure, the number with the blue is exponent. So, 2 is going to be multiplied with its own number 5 times. So, the answer is 32. So, it is much clear now that 2 here is the base and the 5 here is the exponents. How to read power and exponent? This is very interesting as well as very important. Normally, say base number to the exponent number expressed as the ordinal number power. So, 2 raised to 5, say 2 the 5th power. Now, ordinal number first, second, third, fourth, fifth, or you can simply say that 2 the 2 raised to 5 or 2 raised to 5 or 2 the power to 5. Now, squared base. So, whenever any number has power as 2 or power which is just 2, you can just call it square. So, here 2 the power of 2 or 2 raised to 2, it is also known as 2 square. Say that 2 the second power or 2 square. Most mathematicians say 2 squared. So 2 into 2, which is 4. Cubed, yes. So whenever any number or the base has power as 3, it is called cubed. So 2 raised to 3, which is also called 2 cube. 2 to the third power or 2 cube. Most mathematicians say 2 cube. So 2 raised to 3 or 2 cube is also derived as 2 into 2 into 2, which is 2 2s are 4, 4 2s are 8. So your answer is 8. Now, what common mistake generally a student make? Now 2 raised to 5, that doesn't mean it is 2 into 5. 2 raised to 5 is 2 into 2 into 2 into 2 into 2, that is 32, not 2 into 5, 10. 2 raised to 5 does not equal to 10, but 2 raised to 5 equal to 32. So don't make such mistake. Let's say if you have 2 cube, that means 2 into 2 into 2. That means answer is 8, not 2 into 3, 6. So don't make such common mistakes. One more common mistake is minus 2 raised to 4 does not equal to this. Because when you have a bracket, that means negative number 4 times. You always have to mention this bracket there. So when negative number especially is in the bracket, that means negative number is multiplied with its own negative number 4 times. And whenever your power is even, your negative number turns to the positive. But at the same time, the negative number is having odd exponent or odd power, that turn to be the negative result. So without the parenthesis, positive 2 is multiplied by itself 4 times, then the answer is negative. With the parenthesis, negative 2 is multiplied by itself 4 times, then the answer becomes positive. Minus 2 raised to 4, that is equals to minus 1 into this many times plus 2 raised to 4. That means here your answer is minus 16, because negative number you have taken out. So 2 into 2 into 2 into 2, which is 16, and that is again multiplied with minus 1. So your answer is minus 16. But at the same time, if minus 2 is written in the bracket, your answer will become plus 16. Now, so minus 2 raised to 4, as I mentioned to you, it is plus 16, because negative number is having power even. So when even times that negative number is multiplied, it turns to the positive. You can see minus minus plus, minus minus plus. So eventually your answer becomes plus 16. When your exponent is 0. So whenever any number, any bigger number or smaller number having exponent as 0, okay, so eventually your answer is going to be 1. Let's say 2 raised to 0, that is 1. 4638 to the power 0 is equals to 1. So any number except 0 having power as a 0 or exponent as a 0, that turn to be 1. 0 raised to 0 is undefined, because no 0 can have a power as a 0. When your exponent is 1, so any number is having exponent as a 1, the answer is going to be the same number. Let's see, 2 raised to 1, which is 2. 4638, the power 1 raised to 1 is 4638. Any number raised the power 1, the same base as any number. 0 raised to 1 is 0, that means 0 one time, so answer is 0. Now exponent 1 is usually invisible. We never write 1 as the power. We understand, I will never write 2 raised to 1, I will simply write 2. I will never write 5 raised to 1. I will simply write 5. The invisible exponent 1. So 2 raised to 1 is 2. 4638 raised to 1 is 4638. Any number with the power 1 is the same base as any number. 0 raised to 1 is 0. The invisible exponent, if you have a 1, so you just see here I have not mentioned 2 raised to 1, I have simply written 2, or 4638 or any number, we will just write the as it is, because we will not write the power 1 as it is invisible. Write the power as the product. So power is equals to, write the shortcut way, that means 2 raised to 5, that is 2 into 2 into 2 into 2 into 2. So 5 times, instead of writing 5 times, I will simply write 2 raised to 5. Find the value of product. So what you can do is 2 raised to 5, you just simply expand them and you multiply. So when you multiply, you will get the answer. So that is 32. Write the prime factorization using exponents. Now 125, you have learned prime factorization in your class 6 and class 7. So when you have a prime factorization of 125, you get 5 into 5 into 5. That means you will write 5 cube or 5 raised to 3. So the product of 5 into 5 into 5 or 5 cube is going to be 125. So you can write either of the way. Congratulations! Now you know how to write a multiplication problem as a product using factors or as a power using exponents. So you know how to evaluate and find the value when any number is having power. We'll have more revision about this in this part 1. Let's have quick recap. So first law is product law. That means when you have same base and different powers, your powers are going to be added. Here you can see a raised to m into a raised to n. So your base is same, which is a, but your powers are different. So you can simply add your powers keeping your base same, which becomes a raised to m plus n. I'll just give you example. If you have 2 raised to 2 into 2 raised to 3, that means you have base 2 and power 2 and 3. So your powers are added here, which becomes 2 raised to 2 plus 3, which is equals to 2 raised to 5. So your answer going to be 32. When multiplying two powers with the same base, just add their exponent. That is the product law, law number 1. Now law of exponents, in that we have a quotient law, or you can say law for division. So whenever you have same base but different powers, you can simply subtract them. So a raised to m divided by a raised to n. So here it becomes a raised to m minus n. When dividing two powers with the same base, just subtract the exponent. That's our law 2. Now power law, power to power. So here it is a raised to m to the whole n. So power to the power gets multiplied. So m into n, that becomes a raised to mn. To simplify any power of power, simply multiply the exponents. Powers with the different base. So here you can see that a raised to n, b raised to n. So what is common here? The power. But bases are not same. So what will you do is, you will just multiply your base and put the power as the common. ab whole raised to n. Powers with the different bases. So you can again see here a raised to n divided with b raised to n. So what will you do is, you will simply divide a and b and keep power common. So dividing different base can't be simplified unless the exponents are equal. Now 0 exponent, we have already learned that any number with the 0 exponent turn to be 1. So a non-zero base raised to a 0 exponent is equal to 1 exponent. So whenever any number is with the negative exponent or negative power, you have to take that number into denominator. So suppose the number is in a numerator, you will take the number to the denominator, so the power turn to be the positive. But if the number is itself in a denominator, you will reciprocate it and bring it to the numerator. So your power become positive. Your number or base could be negative, but your power cannot be negative. So any time if you face any example with the negative power, the first task you will perform is you will always convert your number from numerator to denominator, and so your power gets positive. So a non-zero base raised to a negative exponent is equal to the reciprocal of the base raised to the positive exponent. So I hope you have learned all this laws in short. Now for the next presentation or next part, we will do all the examples which are covered under this chapter, as well as we will do the standard form. I hope you have understood a simple laws for powers and exponent. Just go through this part again and again. So whenever you see part 2 or the board classwork or the examples solved by me, you will have the better understanding. So after part 1 and part 2, you will complete the note exercise or the textbook exercise in your classwork. Hope to see you again. Thank you. Take care. Bye.